Hi everyone, students. Today we'll take up some important questions from chemical equilibrium for the NEET and UG exam. Okay students, get yourself ready with pen and paper. These are the question. Question number 1. Two, three, 4 and 5. Okay. So you take a screenshot and first you solve it by yourself. Okay, so let's start from question number 1. So here students, 2 moles of gas, okay, A and B moles of 4 moles of B gas, okay, are left to allow, and they are allowed to react to form the gas AB. So the reaction is given here. A2 plus B2 gives 2 times AB. The value of Kc is given as 4 at 27 degrees Celsius. So what is the concentration of AB when equilibrium is achieved? Okay, so we have to find the concentration of AB at equilibrium. So as usual, let's construct the initial change equilibrium table, or we usually known as ICE table. Initially there is 2 moles of A and 4 moles of B, and initially 0 moles. After this, let's write change. Since there is 2, so plus 2x, there is 1, so minus x. At equilibrium, 2 minus x, 4 minus x, and 0 plus 2x is 2x, twice x. Okay. So E is equal to I plus C. Okay, we calculate like this. So these are the moles at equilibrium. To express in terms of concentration, we have to divide the number of moles divided by volume. Okay, so the volume is A, we take 1 liter, B, we take 3 liter, 3 plus 1 is 4 liter, okay, divided by 4. So this is the concentration at equilibrium. Okay, the value of Kc is given as 4, so let's write Kc is equal to AB square divided by A2 B2. Kc 4, then AB twice x by 4 square, 2 minus x by 4, 4 minus x by 4. Okay, this is the Kc expression. So let's solve here. So I can write here 4 is equal to 4x square divided by 2 minus x, 4 minus x. So 4 cancel. So let's multiply this one. 4 to 8 minus twice x minus 4x plus x square is equal to x square. X square cancel. X is equal to 8 divided by 6. Okay, 4 by 3. So x is 414, 1.33. Okay, so the number of moles, x, the value of x is 1.33. So he asks what is the concentration of AB at equilibrium. Okay, so for AB at equilibrium, the concentration is 2x by 4. Okay, so here let's find concentration of AB is equal to at equilibrium twice x by 4, x by 2, 1.33 divided by 2, that is 0.26 or 12, 1 to 0.66. Okay, 0.66 molar. So the correct answer is C. Okay. Okay then, so then let's move on to the next question. Okay, so let's reaction is given where nitrogen gas reacts with hydrogen gas to give ammonia. N2 reacts with hydrogen gas to give ammonia. And at the beginning, the molar ratio of nitrogen and hydrogen are given in 1:3. For ammonia at the beginning, there is 0 moles. So similarly here, you can construct the I stable ICE. So let's write the changes here. 2, so 2x plus 3, so minus 3x, 1, so minus x. So E is equal to I plus C, so 1 minus x, 3 minus 3x, and 0 plus 2x is 2x. Okay, these are the moles at equilibrium. Okay. Next, at equilibrium, 50% of each reactant has reacted. Okay. At equilibrium, 50% has already reacted to form products. If the equilibrium pressure is P, then the partial pressure of ammonia at equilibrium. Okay, we have to find the partial pressure of ammonia at equilibrium. Okay, students. So here we have to find partial pressure. So I can write here partial pressure of ammonia is equal to mole fraction of ammonia into total pressure. Okay, so this is how we find. So here the total pressure is given as P. Okay. Okay, first let's find X. So here it says that at equilibrium 50% of each reactant is reacted. Okay, so here let's find 1 minus X, okay, is equal to 50% of initial mole is 1. Okay, so 50% of 1, so 1 minus X is equal to 50%, 0.5. Okay, so X is equal to 0.5. X is equal to 0.5. Okay, then number of moles of nitrogen will be 1 minus X. So let's find right here. For nitrogen, number of moles is 1 minus X is 0.5. So 0.5. Number of moles for hydrogen will be 3 minus 3x. 3 minus 3 into 0.5. The 1.5. So 3 minus 1.5 is 1.5. And the number of moles of for ammonia will be twice x. 2 into 0.5. That is 1. Okay. So let's find total moles. Total moles is equal to 0.5 plus 1.5 plus 1. So 1.5, 1.5. Total number of mole is 3. Okay then. So at last, let's find the partial pressure of ammonia. So partial pressure of ammonia is equal to mole fraction. Number of moles of ammonia is 1. Okay, 1 divided by total number of mole is 3. This is mole fraction. Number of moles divided by total number of moles into total pressure. Total pressure is given as P. Okay, so P by 3. So the partial pressure is P by 3. So the correct answer is A. Okay, students, let's take up the third question. Question number 3. So calcium carbonate is taken in a 1 liter vessel and heated up to 1000 Kelvin. The Kp for the reaction is 1.5 atmosphere. Calculate the moles of calcium oxide present at equilibrium. Okay, so we have to find the moles of calcium oxide present at equilibrium. Okay, so Kp is already given. So first let's write Kp. Kp is equal to PCO2. Okay, here since it is solid, these terms will be not included in the Kp expression. So Kp is equal to 1.5 atmosphere. So pressure of carbon dioxide is 1.5 atmosphere. Okay, so we have to find the number of moles. So here let's apply the ideal gas equation here. Pv is equal to nRT. So let's apply it right here. P is 1.5 atmosphere. Volume is 1 liter. Number of moles N are 0.082 liter atmosphere. Kelvin inverse, mole inverse into temperature is 1000 Kelvin. So let's cut the unit first. ATM, liter, Kelvin inverse, Kelvin. Okay, so the only unit left will be mole. Okay, so N is equal to 1.5 divided by 0.082 into 1000 mole. Okay, so 1.5 divided by 82. Okay, 1.5 divided by 82. So after calculation, students, 1.5 divided by 82, I get here 0.018 moles. Okay, 0.018 moles. Okay, so the correct answer is 2. Okay, okay then students, let's move on to the next question here. How many moles per liter of PCl5 has to be taken to obtain 0.1 mole of chlorine if the value of equilibrium constant Kc is 0.04? Okay, so Kc is given, and the requirement is that we have to obtain 0.1 mole of chlorine. So in order to obtain 0.1 mole of chlorine, how many moles per liter of PCl5, that is the reactant, should be taken? Okay, so we have to find the moles required. Okay, so first let's write the reaction here. PCl5, PCl3 plus Cl2. Okay, they are all gases. Okay, so first let me take X moles of PCl5 is initially taken. Okay, that is the required amount, 0. Then after that, A moles of product is formed, minus A, X minus A, 0 plus A and A. Okay, this is I, C and E. Okay, then let's apply Kc. PCl3 Cl2 divided by PCl5. Kc is equal to A into A divided by A minus X. Kc value is 0.04. A is given that 0.1. Okay, 0.1 mole of chlorine is formed. So here the number of moles of PCl3 and chlorine are same. Okay, here 1. Okay, so when it is 0.1, what will be 0.1? Okay, sorry, it should be X minus A. Okay, here X minus A. So X minus 0.1. So here 4 is equal to 1 by X minus 0.1. 4x minus 0.4 is equal to 1. 4x is equal to 1.4. X is equal to 1.4 by 40. X is equal to 7 by 20. I can write 7 by 20. Okay, 7 to 14. Okay, 7 by 20. So after calculation, 7 by 20, 35 by 100, 0.35. Okay, 0.35. So the number of moles of PCl5 required is X, which is obtained as 0.35. Okay, so the correct answer is 3. Okay, Okay, let's move on to the last one here. For the reaction, A reacts with B to gives 2 moles of C, A 1 mole, B 3 moles, and give 2 moles of C at 27 degrees Celsius. 2 moles of A, 4 moles of B, and 6 moles of C are present in 2-liter vessel. Okay, if the Kc for the reaction is 1.2, then the reaction will proceed in direction. Okay, so students, for direction, we have already studied here Kc and QC. Okay, reaction quotient. If the Kc is greater than QC, then the reaction shift in forward direction. If QC is greater than Kc, the reaction moves in shift in backward direction. Okay, if QC is equal to Kc, then no shift occur. Okay, it remains at equilibrium. Okay, so let's find Kc is already given here, so let's find QC, reaction quotient. Reaction quotient is equal to C, number of moles is 2, divided by A, B 3. QC is equal to C. Okay, number of moles of for C, number of mole is 6 by volume is 2, divided by A. For A, number of moles is 2 by volume 2. For B, number of mole is 4 by 2 cube. Okay. QC is equal to 3 square divided by 1 into 2 cube. Okay. QC is equal to 9 by 8. 9 by 8. Okay. 9 by 8 is 818, then 818, 1.1. Okay. So here the value of Kc is 1.2. Kc is equal to 1.2, and we obtain that Kc is greater than QC. Okay, here Kc is greater than QC, so the reaction will shift in forward direction. Okay, so the correct answer is A. Okay. Okay then, students, that's all for today. We'll meet again in the next video. Okay. Okay then, bye students, have a good day.